Welcome back, chemistry students. This is Dr. Tullis, and this section is all about elements. You'll be able to identify the name or symbol for an element given its symbol or name and use the term atom, element, and molecule correctly. So let's look at some early ideas in atomic theory. Greek philosophy originally proposed 4 elements: earth, water, air, and fire. This idea lasted nearly 2,000 years, and this brings me to Disney's movie Elemental. I want to show you a little clip.
There are a million reasons why this can't work. A million no's. But there's also one yes. We touched. And when we did, something happened to us. Something impossible. We changed each other's chemistry. Because of you, I learned to embrace the light while it burns. It's okay.
No, it's not okay!
I have no regrets. You gave me something people search for their whole lives.
But I can't exist in a world without you. I'm sorry I didn't say it before. I love you, Wade. There's a word in Firish. Bishok. It means embrace the light while it burns, because it won't always last forever. Can't talk, in a hurry. And don't let my dad catch you out here again.
What? Come on, he doesn't like my landscaping? Anyway, June Bloom is coming, and you just got to be my date. Cause check it out. I'm all grown up. And I smell good. Ow! My queen.
Sorry, buddy. Elements don't mix. Flame, gotta go.
Come on, go to the festival with me. You never leave this part of town.
That's because everything I need is right here.
Whoa. How'd you do that?
It's the minerals. Check this out.
Awesome! What's this?
There were lots of great references in that movie Elemental. That last one was actually kind of similar to the Walter White, where he was spraying different metal solutions into the Bunsen burner and we saw different colors. And just like she was running across different minerals, we're able to see the different colors, so there's obviously different metals that are being expressed. She also said in the clip before that, the elements don't mix, but we do know that elements mix. And I loved that when fire and water were coming in contact, she said that they changed each other's chemistry. So modern science does not support the classical elements to classify types of substances. The atomic theory classifies atoms into more than 100 elements, which may form compounds and mixtures. In a way, however, the classical elements do align with the 4 states of matter that modern science has agreed on. Solids, liquids, gas, and plasma goes along with earth, which is solid, water, which is liquid, air as a gas, and fire as a plasma. We talked about elements just a little bit when we were talking about pure substances, but each element on the periodic table is abbreviated using a chemical symbol, which is either 1 or 2 letters long. Most of the time, the symbol is derived from the name, like C is carbon, Al comes from aluminum. When a symbol has 2 letters, the first is capitalized and the second is lowercase. Elements by themselves are neutrally charged. Currently, there are 119 known elements. About 90 are found in nature, and the remaining have been created by scientists in the lab. Here's a periodic table that's telling us all about elements here. In group 1 and 2, we have our transition metals. We've got noble gases over here. We've got halogens here, more nonmetals. We've got metalloids. We have our lanthanides and actinides in row 6 and row 7. I have another clip that I want to show you from the Black Panther.
Baba,
Yes, my son.
tell me a story.
Which one?
The story of home.
Millions of years ago, a meteorite made of vibranium, the strongest substance in the universe, struck the continent of Africa, affecting the plant life around it. And when the time of men came, 5 tribes settled on it and called it Wakanda. The tribes lived in constant war with each other until a warrior shaman received a vision from the panther goddess bust, who led him to the heart-shaped herb, a plant that granted him superhuman strength, speed, and instincts. The warrior became king, and the first Black Panther, the protector of Wakanda. 4 tribes agreed to live under the king's rule, but the Jabari tribe isolated themselves in the mountains. The Wakandans used vibranium to develop technology more advanced than any other nation. But as Wakanda thrived, the world around it descended further into chaos. To keep vibranium safe, the Wakandans vowed to hide in plain sight, keeping the truth of their power from the outside world.
Now here's an example of this vibranium. It's a made-up element, so it's more for the storyline, but it is not found on the periodic table. One element that is found on the periodic table, though, is radium. And these are 2 highly recommended shows. This Radioactive is on Prime. Radium Girls is a movie, but 2 really amazing shows / movies to watch that are both based on a true story. So here's a small clip.
Welcome to American Radium. You are paid 1 cent per dial.
Your work suffers, Miss Cavallo. The 8 looks like a fat toddler.
This month's top painter, Josephine Cavallo.
Will you help me practice my feeling spaces? I'm studying. I have to be ready to be discovered and go to Hollywood. I want to find a tomb like Tut's, and I'm an archaeologist. Joe, will you be ready in 5 minutes? Joe?
Don't come in, please.
Joe? I don't know what's wrong with her. I'm dizzy. My joints ache. I lost a tooth and 2 others are loose. Do you know what's wrong with me?
Absolutely nothing. You're healthy as a horse.
Where do you work?
American Radium.
We're dial painters. We believe that exposure to radium can cause devastating tissue damage.
Radium is good for you. Everyone knows that. What does this mean for us? You take American Radium down. There's a doctor that can test if your bones are radioactive. Bessie, you sound crazy. I'm not losing my job over this.
Go watch the movie. Let's get into atoms and molecules. Atoms are the smallest particle of an element that has the characteristic chemical properties of that element. Now, some elements, like neon and argon, are found in nature as just isolated atoms by themselves. Others are found as molecules. If they're found by themselves, we say that they are monatomic, meaning they are a single atom atomic in their molecular form, like helium by itself. It's just He. Other elements contain 2 or more atoms in their molecular form, like hydrogen is not just H. When it's in nature, it's H2. So diatomic. There's 2 H's together, like this. 2 H's bonded together. It's not just H. Another form of oxygen, ozone, has 3 O's that's all combined together. Some oxygen has 2 O's that's also diatomic. Sulfur, S8, has 8 atoms. All elemental molecules are made of atoms of a single element. Notice S8, it's still all S, all sulfurs. O3 is all O's. H2 is still all H's. So a molecule is more than one atom in which the atoms are held together by chemical bonds. Now, how do we know which ones are diatomic? Like two O's want to be together, not just one O, or two chlorines that want to be together. So these are diatomic, two atoms together. It's really important to remember the diatomic ones. There's two ways that I remember. Brinkelhoff, and here's a funny thing. It says, meet the Brinkelhoffs. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. Brinkelhoff. Those are all of the diatomic molecules. Or another way up here, have no fear of ice cold beer. In H, obviously you can go on down and see who all of those elements are. It's the same 7 as these guys. Here's just an interesting fact that almost 1/3 of naturally occurring elements are used to make a cell phone. Look at the ones that's involved with making the case components, the processor, the screen, and the battery. It's just a little interesting information. So now that we know about elements and atoms and molecules, we're going to move on to compounds. We know that elements are pure substances, and so are compounds. That's review. Compounds are held together by chemical bonds and have a fixed ratio of elements. Even though there are only 119 known elements, this is wild. There are over 100 million different compounds that have been identified. The properties of a compound are different than the elements that make it up. And compounds can be broken down by a chemical reaction. Water, H2O, with a chemical reaction can be broken down into hydrogen gas and oxygen gas. Carbon monoxide is one carbon, one oxygen bonded together. Sugar, caffeine, nylon, rust are all compounds. Here are several other compounds that you might see in your everyday life. And what's interesting, like we said, a compound like NaCl, salt, sodium chloride, is very different from the elements that make it up. Sodium by itself, Na, is a solid, and it's metallic, and it's silver, and it's soft. And chlorine by itself is a gas, and it's yellow, and it's actually poisonous. But when the two react and combine, it forms salt, sodium chloride, which is a white crystalline solid. It is important to distinguish between a mixture of elements and a chemical compound of two or more elements. Pure metallic iron and yellow powdered sulfur can be mixed in varying proportions. But in the compound iron pyrite, there is no variation in composition. Not only does iron pyrite right here have properties unique to itself and different from either iron or sulfur, it has a definite percentage composition. Exactly 46.55% of this compound is iron and 53.45% is sulfur. So here's an example of an element where I have atoms of all the same. Here's another element. I've got diatomic molecules here. They're all O's. All O's. They're oxygen atoms. That is an element. Here I have compounds. One carbon and two O's bonded together. One carbon and two O's. Definite proportions. But here's a mixture. Air. I've got some argon, I have some oxygen, I have carbon dioxide, I have some nitrogens. So those chemical formulas have that ratio of elements that is always the same. It doesn't matter if I'm looking at one water molecule versus another water molecule, there will always be two H's and one O bonded together. The law of definite proportions, or the law of constant composition, tells us that elements are being combined in definite compositions and are the same ratios. A chemical formula tells us the number of atoms of each element in a compound. So this is sulfuric acid, for example. There are two H's, one S, and four O's. So the subscript tells us how many elements before it. So this 4 tells me how many O's there are. There's nothing after the S. If there's nothing, you assume that there's only one of them. And here's what sulfuric acid would look like. This middle yellow ball is signifying the 1 sulfur. We have 2 H's. That would be my white spheres here. And our 4 oxygens would be the red spheres surrounding it. Why don't you pause the video here and tell me whether each of the following is an element or a compound. Bromine and hydrogen peroxide. If you said that bromine was an element, And hydrogen peroxide was a compound? You would be correct. How about this? Identify whether white phosphorus and carbon monoxide are elements or compounds. If you said that P4 is an element, you would be correct because those are all of the same type of atom, and carbon monoxide is a compound. And the last slide of this section is interpreting chemical formulas. So parentheses may be used to clarify atomic composition. For example, this is magnesium hydroxide, and we will learn what the names are for these chunks of compounds that are together. This is called a polyatomic ion. But this 2 on the outside, if it's MgOH2, that tells me that I have 2 hydroxides. So that 2 actually distributes to both of those. That means that I have one OH and a second OH. So 2 O's and 2 H's and 1 magnesium. If there's only one atom of a certain type, there is no 1 used in this magnesium hydroxide. It doesn't say Mg1OH2. Nope, there's no 1. If there's more than 1, then the number of each is written as a subscript. Here we have ethylene glycol, which is a component of antifreeze, and it has a chemical formula of C2H4OH2. So it has 2 carbons, 4 H's, 2 O's, and then another 2 H's, so a total of 6 H's. Can you write the chemical formula for vitamin B6, which is 8 carbon atoms, 11 hydrogen atoms, 1 nitrogen, and 3 oxygen atoms? Pause the video here. Did you get C8H11NO3? How about this? How many total atoms are in a molecule of glycerin and nitroglycerin? And can you tell me the chemical formula of vitamin B3? Pause the video and do these last 2. In glycerin, I added up 3 carbons, 5 H's, and then for the OH parenthesis 3, that would be 3 O's and 3 H's for a total of 14. And for nitroglycerin, that's the 3 carbons, the 5 H's, the 3 O's, and then for the NO2, but there's 3 of them, that would be 3 N's, and then there were 2 O's, but I tripled it, so 6 O's for a total of 20. And vitamin B3 would be 6 carbons, so C6H6N2O, and that wraps up this section.